In this topic, we discuss rational numbers and their decimal expansion. We take some examples. 0.375. It can be written as 375 by 1000 because there are three decimal places. So we have to write 10 cubed means 1000. This can be prime factorized in this manner. 375 is written as 3 125 is 5 25 is 5 5 is, which means 3 into 5 cube. Similarly, 1000 can be prime factorized and written as 2 cube and 5 cube. So 5 cube gets cancelled. It remains 3 by 2 cube. Similarly, 1.0304 can be written as 104 by 100. This can be written as in this manner 2 cubed into 13 by 2 square into 5 square. Here we need not to cancel. Suppose we cancel this one, 2 into 13 by 5 square. Similarly, 0.0875 can be written as 7 by 2 power 4 into 5. Finally, 12.5 can be written as finally 5 square by 2. Here, these are, we know that, terminating decimals. The numerators contain only 2 and 5, 2 or 5, which means the rational numbers which can terminate can have only 2 and 5 as prime factors in the denominators. So this can be generalized. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p by q, where p and q are co-primes, and the prime factorization of q is of the form 2 power n into 5 power m. Only it contains 2 and 5 as prime factors. This means the denominator contain only 2 and 5 as prime factors. The converse of this theorem can be stated as, let x is equal to p by q, where p and q are co-primes, be a rational number such that the prime factorization of p by q is of the form 2 power n into 5 power m, where the expansion which terminates, where nm are negative non-negative integers, then x has a decimal expansion which terminates. Here, another theorem, for non-terminating recurring decimals, let x be a rational number such that the prime factorization of q is not of the form 2 power m n into 5 power m, where nm and m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating. Some examples, we discuss some examples. 16 by 125 is written as 16 by 5 into 5 into 5, which means there is only 5 as a prime factors in the denominator, so it is a terminating decimal. 25 by 32 is also only 2 as a prime factor in the denominator, so it is a terminating decimal. Whereas 100 by 81 can be written as 3 into 3 into 3 into 3, that is 3 power 4. So it contains 3, so it is a non-terminating repeating decimal. Similarly, 41 by 75, the denominator can be expressed in the form of 3 into 5 into 5, which means 3 is a prime factor of denominator, so it is a non-terminating recurring decimal. These denominators are not of the form 2 power n into 5 power m. So, example 3 and 4 are non-terminating recurring decimals.